Good afternoon, friends. So in last lecture we have seen the theorems of differentiation, and also we have seen the change of variable from your Cartesian to your polar coordinate. So this part we have seen in last lecture, as well as we have took some problem related to this particular topic. So in this lecture we'll see the what do you mean by explicit and what do you mean by implicit function. Okay, so suppose this is f of x is equal to, this is 4 x cube minus twice x square plus 6x minus 1. So the given function is in the term of x. Okay, the function in terms of x. Second example, suppose y is equal to x cube minus 6x square plus 9x. Now y is a function of x here, so we can write y is function of your x, because all the x term on your RHS side and y. So this y is called the explicit function of x. Means in this case y is separable from your x. Okay, so y is a function of x, and given y is easily separable from your x, so such a function is called as your explicit function of x. Suppose this is not happen, means every time this is not possible, y is a function of your x or any function in terms of that particular things, this is not. So in that case this is your implicit function. Okay, so regarding this, suppose we have given this particular y is explicit function of x, so this is your y. So this y we can write in terms of what? Suppose we will take x common, so this is x square minus your 6x plus your 9. So this is nothing but x into x minus 3 brackets. Suppose I will plot the graph for this one. So this is my independent variable x. Okay, so y is dependent variable, and I will get a plot. It is just like, okay, so see, x is equal to 0, it is at a 0. X is equal to 3, this is also 0. So this is your x is equal to 3. Okay, so you will get such a nature of your curve. X is equal to 0 and x is equal to 3. So these are the y. Suppose we will plot a dy by, so you can take anything related to this one, dy by dx, and you will get that term. So differentiate this or this term, you will get the same thing. Okay, suppose I will differentiate this one. So this is 3x square minus your 12x plus 9. I will take 3 common. So here x minus x square minus your 4x plus your 3. So I can write this is 3 into x minus 1 and your x minus 3. Okay, so if you solve this, you will get this particular step. So here at x is equal to 1 and x is equal to 3, so I will get a 0 case. So the given nature of the graph, it is just like this is x, this is your y. Okay, and at x is equal to, so somewhere here is suppose my 1, here is my 2, and here is x is equal to 1, 2, 3 obviously. Okay, so in this case x is equal to 0, So if you plot the graph, it is just like this one, and again x is equal to 3, I will get this is 0. So this is my dy by dx. This is basically your gradient. Dy by dx is indicate what? This is your gradient. Okay, slope is indicate your gradient. So that will be the case. So I will not go into the detail. The important part is here. So suppose you can write any function in terms of something. So that is nothing but the given function is easily separable from your independent variable. So in that case, the y is explicit function. Y is called as your explicit function, okay, of your x. Now we'll take a different example. Suppose you have given this is e raised to xy minus your sine of your xy equal to 0. And you say suppose separate y from x. So in this case this is not possible. What I will do, suppose we can take e raised to xy is equal to your sine of your xy, and if you take ln of both sides, then ln this is sine of your xy, okay. But here y is equal to suppose 1 by x ln of sine of your xy. Now see, on L edges the y is present, but on R edges y is again present. So you can't write y is a function of your x. Okay. So here y is not easily separable from x. Okay. So the example is what? So many times in examination they will ask the define explicit function or define implicit function. Okay. So this is when you are given any function and that function is equal to 0, okay, and y is not separable from your x, suppose. So this is indicate what? Your f is function of your x and y, and that is equal to your 0, okay, and y is not easily separable from x, then y is implicit. implicit, implicit function of x. Okay, so what is the definition? Suppose f of xy equal to 0. This is the example, e raised to xy minus sine of xy equal to 0. So same is f of xy equal to 0 and y is not easily separable from your x. So we have solved, but we will not get a clear solution for such a complicated problem. Okay, then y is a function of your y is an implicit function of your x. So you can't write y is function of something x variable. Okay, so this is nothing but your implicit function. The second example, suppose we will take, so many times probably you have heard that particular example. So I am talking about the implicit function. Explicit function is over. So this is your implicit function. Okay, example we have taken. This is e raised to xy minus your sine of xy equal to your g. The second example is suppose x square plus your y square which is equal to 1. Okay, this is what? Equation of circle having the radius is 1. Now in this case, suppose this is y square is equal to 1 minus your x square, and this is your y is equal to plus or minus under root of 1 minus your x square. Okay, so what happened in this particular case? This is not simple. Okay, so this is not simple. Why? You can write. Okay, so this is your might be difficult or even impossible to find out dy by your dx in this case. Okay, so this is the case. Why? That I will tell you here. So you have, this is equation of circle, y square is equal to 1 minus your x square. Okay, and y is equal to plus or minus square root. So this is under root of 1 minus your x square. And suppose you want to find out dy by dx, so that might be difficult using this particular way. We will take example. This is, suppose we will take first is positive root. So this is under root of 1 minus x square, and this I can write 1 minus your x square raised to half. So this is dy by dx. I can write in terms of what? This is half 1 minus your x square half minus 1 into derivative of this term. So that is your twice x. 2 to get cancelled. So what you will get here? So this is x upon under root of 1 minus your x square, and that is nothing but my y. Okay, so derivative is minus twice of x. So here you will get minus sign. So minus x upon y. Okay, suppose we will take plus root minus root, y is equal to minus under root of 1 minus x square. So this is minus 1 minus x square raised to half, and suppose you have taken dy by dx of this thing. So what is the value for that one? So that value, if you solve this one, you will get x divided by y, or otherwise we will solve over here. So this is minus sign is original one, this half is coming over here. This is 1 minus your x square raised to 1 half minus 1, okay, into derivative of this minus x square is minus twice x. So this is minus minus plus, 2 to get cancelled. So x upon, this is under root of 1 minus your x square. So you will get x divided by y. Now see, the equation is same and you will get two different slopes. Basically, suppose you want to find out the tangent to this particular equation. Okay, and this is minus x divided by y. Here you will get x divided by y. This is indicate what? Y is equal to, so this is plus half. Suppose I will plot a graph for this one. Y is equal to under root of 1 minus x square. So this is my x is equal to 1, x is equal to minus 1, and at x is equal to 0, here I will get y is equal to 1. Okay, so this is positive half of your circle. So basically this is your circle, this is your x, this is your y, and you will get one particular circle. So this is positive half of that one. Suppose you will take this negative, then you will get a lower half or negative half of that particular circle. So this is plus 1, this is minus 1, this is your x, this is your y. Now when you plot a graph for this one, dy by dx versus your x, so the given graph, so I will use this one. Okay, so this is x and this is my dy by dx. So I will get such a type of a graph. Okay, for this case I will get a positive slope. Okay, so this is my x, this is my dy by dx, and I will get such kind of a thing. Okay, so means this is a complicated situation. So you can't get easily y is separable from your x. So for that purpose we have to use one formula to find a dy by d. x. Okay, so we'll start with your circular case. So in this case, what we'll do, I can take this my function. Okay, so this is x square plus y square equal to your 1. I will differentiate with respect to x. Okay, and y is a function of your x. Okay, so the differentiate given equation with respect to x, and y is your function of x. So this is your x square. So differentiate with respect to your x. So I can write this is twice x plus differentiation with respect to the y, and y is a function of your x. Then I can write this is 2y into dy by dx. This is very simple. Suppose I want to find out, this is y is a function of your x. Okay, and you want to find out, so y dash, which is nothing but a given this and into that part. Okay, suppose it's square. Okay, so this is 2 times that particular function into derivative of that particular function. So this is the case, 2y times only. Remember, differentiate regularly. Suppose here is y cube, then I can write 3y square and into dy by dx. That is the case. Okay, and constant derivative is 0. Then what I'll do, I'll send this 2x that side. So this is 2y dy by dx is equal to minus twice x, and this dy by dx is equal to minus 2 to get cancelled, so x divided by. Okay, now suppose you are given any point. So here we can find out the 2 things. If you remember here, dy by dx is indicate what? Your slope. Okay, slope. So I can write this is y minus your y0 suppose, and this is x minus your x0. This is equal to minus x divided by your y. And suppose you are given the any point, okay, origin point suppose. So in that case, suppose you will solve, you will get line equation or something. Okay, so that thing you can easily find out. So here you can find out the equation of your tangent line. Second, you can find out a tangent at that particular point. So you have provided. So we'll take that particular problem. So important thing is over here, suppose any function and that is not easily separable from your x. So in that case, what we'll do, we'll differentiate a given function in terms of some independent variable, okay, and the other variable which are in terms of x. Differentiate here and you will get dy by d. So that is indicate your slope or the tangent to that particular. So this is equation, and that is nothing but your tangent dy by dx at one particular point. So suppose you will get x and y value, put that value over here, you will get a slope. Okay, slope of that tangent line. This is overall thing over here. Okay, so what is the use of implicit function? Okay, so implicit function to find the equation of a tangent line. So use is the implicit function is useful to find the equation of a tangent line, okay, to the curve. Equation of a tangent line to the curve at a point. So any point, if you are, this is one particular curve and you are given the tangent to that particular point, this point suppose you will provide, so you will get that equation as well as slope and everything you will get from that particular thing. So this is one thing is simple. So we'll take one problem related to this. So first problem, find the slope of a tangent. Okay, find the slope of a tangent to the curve x cube. Find a slope of a tangent to the curve x cube minus 3xy square minus y cube equal to 0. Suppose here we'll take x common. So it is not easily, y is not easily separable from your x. So this is your implicit function. The first condition is verified. Second thing, this is f of xy equal to 0. Okay. So what we'll do, we'll direct differentiate with respect to x, and your y is a function of x. So we can write 3x square plus here the product rule. Okay, so for differentiation of x, so this is 3y square plus this will be your 3x, derivative of your y square is 2y into derivative dy by dx minus 3y square into y cube derivative. So this is dy by dx equal to 0. Okay, so in this case I will take dy by dx suppose common. Okay, so that will be one, or we'll write most of 3x square plus your 3y square plus 6xy, okay, minus 3y square into dy by dx equal to 0. Okay, so I'll send that term over here, this term divide, so I'll get dy by dx, or I'll write one more step, 6xy minus 3y square equal to minus 3x square plus 3y square. So this is dy by dx, which is nothing but minus 3x square plus 3y square divided by 6xy minus 3y square. Okay, now you have to find a slope of a tangent to the curve. This is one particular curve, and you have to find out a slope of a tangent to the curve at a point. What are the point? X equal to 2 and y is equal to minus 3. Okay, so we have x equal to 2, y is equal to minus 3. So this is dy by dx, okay, at a point 2 and minus 3. So this is nothing but minus 3. This is 2 square plus 3 minus 3 square divided by, this is 6, 2 minus 3 minus 3 minus 3 square, and this one. So you will get the answer directly. I'll write 13 divided by 21. Okay, so basically this is indicate your slope to the tangent line at this particular point. Okay, and that is nothing but your positive one. Okay, so obviously this will be in a increasing case, 13 divided by 21. Second, so this is one way. So use of implicit function to find out the slope of a tangent at one particular curve. Which point is given? X equal to 2 and x equal to, only differentiate and this one. Okay, so this is one case. Second example they will provide, suppose find the equation of a tangent line. Find the equation. What is the problem? Find equation of a tangent line. So you want to first, we have find out the slope of a tangent line to the curve. Now here equation of a tangent line to this. Okay. So this is x cube minus 3y square plus xy plus 21 equal to 0. Okay. At a point 1 and 2. Okay. So this is particular example they have provided, x cube minus 3x square. Suppose we want to separate x from y, so this is not possible in this particular case. So obviously this is your implicit function. Then my first aim to differentiate a given function in terms of x, and y is a function of your x. So this is nothing but 3x square minus, this is 6y dy by dx. I will directly write down, you know probably. This is y plus this is x dy by dx constant, which is equal to your g. Okay. Then what we'll do, we'll separate divided by dx term from here. So this is 3x square plus your y. Okay. Plus I will write this x suppose first minus your 6y dy by dx equal to your 0. So from this dy by dx is equal to, I will send this term over here. So this is minus 3x square plus your y square divided by x minus 6y. Okay. So in this case we have to find a tangent, equation of a tangent line. Okay. So equation of a tangent line at a point. Which points are given? So this step I can write in terms of what? Y minus suppose y0 divided by this is x minus your x0 is equal to, this is minus, this will be 3x square y square x minus 6y. Now we have given the point 1 and 2. Okay. So that is nothing but what? X equal, y is equal to, y not equal to 2. So this is 2 divided by x minus 1, which is equal to minus 3. This is 1 square plus 2 square divided by 1 minus 6 into 2. Okay. So this is implies y minus 2 divided by x minus 1, which is equal to, this is 3, this is your 4. Okay. So this is 7 over here minus sign, and here is 12 minus 1 is 11 minus 11. So minus become plus. Okay. So this, suppose we will send this term over here, this term over here, and from this particular step you will get, if you solve, so y is equal to, you will get over something is wrong, so tangent to the line. So finally you will get the equation 1/2 time x plus 13 divided by 7. This is indicate what? This is y is equal to mx plus c. You can check. So this is the probably y is equal to 1/2 times x plus 13 divided by your 7. So this is equation of your line. So what you have to find out, find the equation of a tangent line. So this is equation of a line at that particular point means tangent. So having the slope is 1/2 and the center is your intercept. C is your intercept. So 13 by 7. You can check little bit over here. So this is the case. Okay. So in today's lecture we have seen two functions are there. Okay. So first is your explicit function. Okay. And second is your implicit function. Okay. So here, so y is suppose f of x. So y is implicit function of your, y is called as your explicit function of your x, and the example means we can write y is a function of some variable or any function which is in terms of some variable. So that we can write, suppose this is x cube minus 3x square plus 12 or something that equal to, or suppose 12. Okay. So the given function in terms of that one. So this is your explicit function. Implicit function means the y is not, means you have, this is f of xy which is equal to 0 and y is not easily separable from x, then this is your implicit function. So we have to follow. So probably in book they have find out one things, this is dy by dx. So this is dy by f by dy by x and divided by dy by f by dy by y. So probably this is I have to search, this is not authentic formula, so don't go with this one. Every time you have to go just take a differentiation with respect to the x as well as y is a function of your x, and just whatever whenever you have a differentiation of y, that time you have to multiply dy by dx. Okay. So this is the case in case of your implicit function and your explicit